Okay, so let's get started. Welcome everyone for the first day of the event. And in this session, we are going to talk about the new XDR, which is completely overhauled. So just before we go deeper into the session, just a few things to remember about this webinar. We are doing this live, so we may potentially have some network issues, but I have with me Andrew Gooding, Andy, who is a Global VP of Engineering. So in case something happens, he will be taking over this presentation, and he will also be answering your questions while the session is going on. So if you have any questions, like while doing the session, you can leave your questions and he will be answering. So at the end of the presentation, I will be picking like some questions and probably repeating the answers again, just for the benefit of everyone. Okay, so you might have heard that multi-data center architecture is the defining feature for the 5.0 release. So there are two components which are driving this. One is XDR and the other is the multi-site clustering. For somebody who is hearing about XDR for the first time, it stands for cross data center replication, and it is the component which is responsible to replicate data across multiple clusters. So what is the difference between XDR and multi-site clustering? So in case of XDR, XDR replicates data across multiple independent clusters which may be sitting across different geographies. Whereas multi-site clustering is a single cluster which is stretched across multiple different data centers, and the replication happens synchronously within that cluster. Whereas in case of XDR, the replication happens asynchronously. So there are different trade-offs in terms of latency versus consistency between XDR and multi-site clustering. So those are the things you need to take into consideration before deciding to go with XDR or the multi-site clustering. Okay. So a quick peek into the evolution of XDR. So this slide has this magic property of revealing your age. So if you understood this slide without me explaining anything, I would bet that your age is at least 30 years, or to be more conservative, I'll say at least 35 years of age. So why is that so? So this slide basically is capturing almost 8 years of evolution of XDR. So for somebody who is with Aerospike for a very long time, they would understand this. And thanks to all of you, like all the customers, like who are with us throughout the journey. So when we initially did XDR, so literally the Aerospike process and XDR process were two different processes running on the same machine, communicating with each other and shipping the records. So there are both performance issues and consistency issues in that model. So XDR is a component which is responsible for logging the transactions into a digest log and reading the records and shipping the records at a later point in time. So imagine situations like where XDR process is down, but ASD process is up and running. And because these two separate processes are communicating over an end pipe or a TCP connection, there are performance implications because of that also. So what we did in 3.8 is we completely brought XDR into Aerospike. But when we did that, we did not fully integrate XDR into Aerospike. So it continued to have its own client submodule, and it had its own threads, it had its own data structures. But at least we covered the consistency and some of the performance issues. So now, like in 5.0, we are actually completely integrating XDR into the Aerospike module. So XDR can tap directly into the data structures of Aerospike. So to read the records, it uses a threading model, and we will be going deeper into what all we did in 5.0. Okay, so why are we doing this now? So I would like to say like we're doing this now because we are smarter, but that's not true. It is the effect, but not the cause. So what are the two main things like which helped in this is like one, a whole bunch of feedback that we got over time from the customers, and other independent features that evolved in Aerospike over time. So though I was putting it politely that this is a feedback, this is really what customers hated. So customer hated the fact that the DCs are coupled. So what do I mean by the DCs are coupled is that like one DCs can affect the other DCs. We'll talk in more detail about that. And static DCs, so if a customer need to add a new DC to the running cluster, you need to shut down like one node at a time and keep adding DCs. So that's very painful in terms of operations. And digest log, if you had been using Aerospike, I'm pretty sure you had some run into digest log issues in the past. So, and at the same time, like we also added a lot of very critical features in Aerospike, which made this possible. So if we had only customer feedback saying that like we want to get off this, but we did not do anything about the other features that we did in Aerospike, we will not be able to satisfy the requirements that evolved over time. So what are the main things that affect or that helped in this feature is the last update time, or simply LUT. So when the XDR was implemented initially, we did not have LUT in Aerospike. What Aerospike had traditionally was something called expiry time or void time, which is based on a TTL, but not really the time at which the record was updated. So in the slide further, like we will see how we are exploiting the LUT in this new design. And the other very, very important thing that it was necessary is the partition balancing algorithm that we have. So now the partition balancing algorithm is very robust and very clearly defining the boundaries of master handoffs. So partition balancing is the one decides who is the master for which partition at what point in time. And it clearly defines boundaries of when the partition is handed from one node to the other node. When a new node is added or an existing node is gone, so it moves the masters and pros from one node to the other node. So, and the other things like we also made the storage format very close to the wire format. And the other thing is the transaction execution model. In fact, like we took a detour from the XDR project to actually do this thing where we changed the internal transaction execution model to not just do your reads and writes, but also take care of XDR reads, XDR shipping, everything. So now the service threads are the workhorse functions for what happens in the entire system. Okay. So so what are you going to get because of this? So when the product management team comes and says like we want these 3 features that customer wants, you can be pretty sure that engineers won't stop at those 3 features. So that's what happened with XDR also. So we ended up like implementing a lot more nice things, keeping the future in mind. So if we need to add more features down the line, we need to be ready for that. So as requested, like of course, like decoupling of DCs is there, and we'll talk in more detail later. Now the DCs can be dynamically creating, and for the newly created data centers, you can add namespaces, and we also have a nice cool feature to do rewind functionality where you can go back in time and ship records. Okay. While doing this, like we completely rewrote the client functionality that XDR uses. Okay. So so earlier XDR used to use the C client module that was public, which our customers can use, but it had a lot of unnecessary components that XDR doesn't literally need. So we made a very lean and mean custom client for XDR because XDR need to do only writes and it doesn't need to do much beyond that. So and there are a few customers like who are using change notification features where events about changes will be delivered to the external system. It had performance issues and stability issues. Now it's completely rewritten and very efficient now. Overall, like I'm very proud to say, like we have a very good design which is meant for low latency and high throughput. How did we achieve that? Like by using more cache-friendly algorithms and avoiding locks as much as possible while doing that. The other thing like we did is completely rethought about how the configuration should be done. Now, like a lot of the configurations earlier were only at DC level or at the namespace level, but what we have now is per DC per namespace level. This gives actually a lot of flexibility, and you'll shortly see what that is about. And as engineer, like at the same time, like I take pride in doing all these features with lot fewer lines of code. So in terms of the XDR module itself, we got rid of like about 6,000 lines of code, purely XDR module. And we were using other third-party libraries to do other functionality in XDR. So that gained about 375,000 lines of code. That's a huge deal. So you might think like, okay, like getting rid of lines is not a, so what is in it for me, right? Basically, fewer lines of code means fewer bugs. So now you may ask like, okay, am I going to get all of this for free? Well, almost. We actually invested a lot of time during the project to make sure that it doesn't upset the existing functionality, and the upgrades also are very smooth. So the new XDR supports almost all the features that were there in the old XDR, like TLS, authentication, compression, hotkey handling, all of it. So the only feature which is missing in the new XDR is the delta, what we call the delta bin shipping, where we ship the bins, only the bins which change in a transaction. But that is also scheduled for the subsequent release of the XDR in the later releases, the next quarter. So absolutely, there need not be any application changes. XDR was never a component which would affect the applications, but just saying it to clarify. And so, if you want to use 5.0, you need to come to 4.9 as a jump version. So 4.9 is a jump version for 5.0 release. So what that means is like to upgrade to 5.0, you definitely need to come to 4.9 and then come to 5.0. So why is that so? So because like we actually preloaded some of the functionality which implemented in 5.0 in 4.9 itself. So 4.9 now knows how to talk with 5.0 nodes. So to make the upgrade much smoother. So 4.9 can talk to both the previous versions like 4.8, 4.1, all of that, and also like 5.0. So when 5.0 nodes are around, it keeps informed about the 5.0 nodes as if they are also 5.0 nodes, part of the functionality, not all of it. And God forbid reason, like if something goes wrong in 5.0, you can always downgrade to 4.9. So we made sure that is also possible. So this is where actually a lot of the time went. And there is a small cost to pay for this new feature, like which is basically some extra memory, because in lieu of the digest log, we are having something in memory transaction queue. So we'll talk about that in a little bit of detail later. But when you're doing capacitive planning, you need to make sure that you are giving some extra memory to these nodes. As a thumb rule, I would say like 1 GB per namespace per data center. Okay, so just something to keep in mind. So what is the bad news now? Not so much, but some of the backward incompatible changes, like I was alluding to, is 5.0 will not cluster with 4.8 nodes. It will only cluster with 4.9 nodes. Okay, but that doesn't mean that it will not ship to 4.9 or before. Okay, so if you are sitting on a 4.9 or a 5.0 cluster, it can ship to a destination cluster which is running on anything above 4.1. And why specifically 4.1 is that is the point at which we changed things about authentication. So that is the reason we want to support up to that and not carry baggage which is like much older than that. So as I said, like now the configuration is different. So you need to change your configuration files. We'll talk about that also in the coming slides. And the stats, some of the old stats are irrelevant. Like for example, digest log stats, they're irrelevant because the design is completely different now. So some new stats will be there. So you need to update your dashboards or alerting tools that you have. So the alerting tools that Aerospike provides are already updated to handle the new 5.0 server. But if you are using any custom one, you need to take care of it yourself. And change notification, like I said, is completely rewritten. So we will not be able to ship events to the older change notification servers. So what is this whole deal about decoupling? So earlier, right, in the older XDR, if one DC link is slow, so it will slow down the entire XDR shipping. So like if you have like one server sitting in West Coast shipping to East Coast and also to Europe, the shipping to West Coast, shipping from West Coast to East Coast also will go at the speed at which it can ship to Europe. So that's not a desirable thing. And also, if like one link is bad, as in some packet drops are happening or connectivity is completely lost, we have a tolerance level of 30 seconds to decide like whether this is completely down or like partially down. So in this 30 seconds, we would completely stall the replication to other DCs also. Obviously, this is also not a desirable thing. So in the new XDR, none of this will happen. So each DC will be shipping at its own speed, whatever it is capable of. Okay, and of course, link disruption will not affect the other DC. So, but this coupling of DC was not only at the network level. So we also had some coupling at the configuration level, because like the configuration to forward a namespace or a set level filter was in the namespace section, and the namespace section just have a list of all the DCs to which the namespace should be shipped to. So if like you change one configuration, let's say forwarding, right? It ends up forwarding to all the DCs. So we actually rethought all of that in the new configuration, and now the configuration is per DC per namespace. It gives a lot of flexibility, and you can use for new topologies. Okay, so I was like depicting one new topology which is possible is when you have a fully connected mesh of three nodes, three data centers where every site is active. Earlier, you could not add two DCs which are read-only DCs, because if for those DCs to get data, you need to enable forwarding in wherever you are adding that DC. So if you add forwarding to that DC, it will end up creating an infinite loop. So so with the new configuration model where your configuration is per DC per namespace, this is no longer a problem. So you can have few active DCs like tight cluster or fully connected mesh, what we call, and keep adding like read-only DCs to it. So it's up to your imagination now, like what more topologies you can use. Okay, and this dynamic DC creation, right? Just to give a quick preview. So earlier we used to ask people to have a skeleton DC without any IP addresses, then add them later, like when you need it. So you don't need to do any of that going forward. So, but you just need to issue info commands to create a DC, add namespaces that are supposed to be shipped to this DC, and you can even set the properties at the namespace level all through info commands. But one very important thing to remember is that these configurations that you are going to do dynamically through info commands are not persisted like many other configurations. For example, ends up high watermark, stop writes, ends up period. When the node restarts, they will be forgotten. So you need to persist them in the config file also. Okay, so this is the rewind functionality, the cool feature that we added. So it allows you to go back in time and start shipping records based on the LUT of the records. Now that we have LUT, this is where one place where we really exploit the LUT. So it goes back and looks up the primary index and then identifies all the records which are updated beyond a certain time threshold and shifts those records. So when you're issuing the rewind command, you can specify in terms of seconds how much back you want to go. So you can say like I want to go back 1 hour or 1 day, or you can say like use a special keyword called all and ship everything in that namespace to the remote data center. So what are the use cases for this? Is basically when you're adding a brand new DC, or sometimes it also happens that like during operations, some configuration mistakes happen. So maybe the set filters are not set properly, so you miss some records and you want to catch up. So those things like you can overcome. While you may, and XDR also had its share of bugs where XDR itself was missing some records, and we used to suggest customers like go and touch the record so that XDR will get a second chance to ship them. So none of that will be necessary going forward. But but just because it is like a cool feature, don't use indiscriminately. I'm like pleading everyone, keep in mind that like XDR is not designed for shipping bulk data. Okay, XDR is meant for incremental shipping. So that's why if you have a huge namespace, right? Let's say 10 gigabytes of data that is to be shipped, or 50 gigabytes of data, it is still going to be efficient to take a backup of that namespace, compress it, SCP the file and the remote data center, and use restore to restore that. So don't do it because it is easy to do, or don't do it because you're feeling lazy to do backup and restore. So please don't do that. I must beg you not to do that. Okay. So what's the big deal about change notification system? Earlier, like we used to use HTTP as a transport protocol for the change notification system. So to handle HTTP, we used to use two libraries on the sender side, libcurl and ng-http2. Libcurl is pretty popular. ng-http2 is the one which supports HTTP v2 protocol. V2 protocol was very performant. So that's why we chose to use do HTTP v2. But over time, like what we realized is these libraries are not mature enough. So we ended up having issues at customer sites, like where some of them were crashes, some of them were like stuck shipping. So shipping would get stuck at the HTTP layer for no fault of ours. So because it is having both performance issues and stability issues, we said like, okay, let's get rid of them so that we are in complete control of what we are going to do. So on the receiving side also, we used to use a web server called Undertow and patch it so that like it will ship further to Kafka, JMS, or Pulsar, whatever it is. So now like XDR will directly talk to a brand new TCP-based server, which is written by Aerospike using Java. So you can be sure of the interoperability across platforms. So XDR will directly talk to this component, and that component will in turn forward the data to Kafka, JMS, whatever it is. So when everything is done by Aerospike, like one thing you can be guaranteed is of like very high performance. And now like all the components are in our control, so we take full responsibility about the stability of these components. Okay, so let's spend a little time going into a little bit detail about the new design. This is not a full, the slide deck itself can be a whole big session or almost a 1 hour session. I can talk in detail, but compress everything into one slide. So the new design is partition-centric design. So what does that mean? So now all the decisions that we take, whether this partition should be shipped to which or till when, so all of the decisions are tracked per partition. Okay, so the picture here is showing actually what happens for one DC. Okay, so the transaction queue, you see like multiple boxes in blue are basically the in-memory transaction queue that I was referring to. So when a transaction happens, basically when a write transaction happens, it submits the transaction into this transaction queue saying this record is supposed to be shipped. Of course, there are some pre-filters that get applied, whether this namespace is enabled or not, whether this set is enabled or not. After passing those filters, the transaction is submitted into this transaction queue. After that, like almost the entire control is done by the DC thread. So you can think of DC thread as a conductor of an orchestra. So it decides who will take care of what, at what time, and at what speed. Okay. So the transactions will keep coming, or basically the metadata of the transaction, not the entire record. So it's just like 25 bytes per transaction that we remember in this transaction queue. So that way we try to be as much memory efficient as possible. So DC thread will dequeue this information about the transaction that happens, and most of the time it will submit the work to the service threads that you are already aware of. So now most of the work after that is done by the service thread. So when I say most of the work, what I mean is all the 4 steps that are depicted here. So the service thread does the local read. The same service thread will do the network write, and the same service thread process the response that is coming for that particular transaction, which of course goes on a particular connection. And if at all the transaction need to be retried, it will put back in the retry queue so that the DC thread will pick it up again. So if you see, like, there are minute details here, right? So entire life cycle of a particular record is spent in a single transaction thread. So that makes it like very cache friendly. So, and these service threads are also tied to a single core. Okay, and we have one ePOL core, one ePOL per core, which is monitoring a bunch of service threads. So the data which is read, shipped, acknowledged back, everything sits on one core, and after that, like in a one particular thread's context. So so we can avoid a lot of locks as part of this. And I also mentioned about the multiple transaction queues. The transaction queues are one transaction queue per partition. Okay. So the granularity of the lock that is taken to submit the transaction is also extremely granular. Okay. So there is very less lock contention. So this is what I meant by a cache friendly or almost lock free design. Okay. So then there are other nice things to this, which is avoiding deserialization of the records. Like I said, like we brought the storage format pretty close to the wire format. So when we read the record from the disk, we don't actually need to create a whole different pattern for that record. So like, for example, especially complex data types like maps, lists and all, it will be very inefficient if I have to open up, form a new structure and then write it to the wire. So we can just read the whole thing, just dump it as a blob into the wire protocol that we have. So that is the beauty of it. And like one slight thing like we got excited to try is the thread level stats. So one thing we realized over time is one of the biggest killer of performance in Aerospike even today is the stats that we maintain. So earlier we used to maintain a whole lot of stats, and every transaction used to update a whole lot of stats. That is actually still killing some amount of performance, but these stats are so critical that we cannot get rid of them either. So what we tried in this project is something called thread level stats. So because these stats are very high frequency, as in every time a record is shipped, like we need to update, every time a record is read, we need to update. So any amount of contention or even cache invalidation of these stats, right, is going to be very inefficient. So what we did is, like, now we maintain all the stats per thread, and only when somebody queries for these stats, then we aggregate the stats. So the stats will be queried only every 5 seconds if you are using external monitoring system, assuming that is your polling frequency, or like every 10 seconds into the Aerospike logs itself. So the readers of these stats are lot less frequent than the guys updating these stats. So so now, like, even updating the stats is not going to hurt the performance of XDR overall. Okay, so yeah, come to configuration. So in a way, you can say that like we completely inversed the configuration. So earlier, there used to be an XDR section which talks about the DCs, data centers, and the data center will only have information about where you will connect, the IPs to which, the seed IPs to which you will connect, and things like that. But most of the other configurations used to sit in the namespace section. Okay, so namespace section used to have information about to what all DCs should this namespace be shipped to, and like I was telling, the some other properties like forwarding, set level filters, and things like that. Now we kind of invest the configuration itself. So now in the DC section, you have to specify what is the namespace you want to ship to. Okay, so and within that namespace, you can specify what are the properties for that namespace that you want to apply. So here I have one example where you are shipping two namespaces to DC1, foo and bar, but when one namespace is enabled for compression, but the other namespace is not enabled for compression. Similarly, I have like one more example where namespace bar is getting shipped to DC2. You can see that hotkey max ms, so hotkey ms is set to 1000 here. So hotkey optimization will be applied when you are shipping to DC2, but not to DC1. So that is the interesting part in this model. So this model allows a lot of flexibility, and like I mentioned in the previous slides, it allows new topologies also if you play with forwarding and things like that. So what all configurations do we allow at namespace level? A lot of them actually. So almost all the configurations that you knew were applicable in the older XDR, we made most of them as per DC per namespace stats. So you can configure compression, forwarding, hotkey handling. So max throughput is something I think which will be very interesting here, because earlier when we used to have max throughput, it was at the DC level. So now it is like per DC per namespace level, but be careful in using the max throughput, especially when it is very different across namespaces for the same DC. Okay, so the set level filters also can be specified now at the per DC per namespace level. And we did this bin filter, which is kind of new. So what we are calling it a bin projection filter. This is different than the delta bin shipping that we had in the past. So this bin projection filter is a predefined list of bin names which will get shipped when the record gets updated. I don't want to get into details, but basically this can be used as a trick or a technique to avoid active-active conflicts in the XDR active-active conflict configuration. So theoretically, yes, you can even So yeah, and so there was actually some request in the past where customer was asking, we want to have a DC per set, because earlier the configuration of DC was in the namespace section. They wanted to control a different DC per set. So don't think that this is not possible in the new design. It is actually possible. So keep thinking how you can use the existing per DC per namespace functionality for the requirement that you have. So how can you use that is basically by ignoring all the other sets. Let's say you want to ship only set 1 to DC1. So you can say ignore all the sets which I did not specify. I did not mention that configuration here, but you can say I want to blacklist all the sets, but allow only this set 1 to this DC. So now you have like DC per set configuration. Yeah, like you can misuse this configuration also to have a DC per bin, but don't use it. Don't. So that's pretty much from my side. So we will be answering few technical questions. I see some of them already here. So I'll go in order. So is there any change in ship latency with respect to previous version? Across long distances, it may not make a huge difference. Like because let's say we are talking about shipping between East Coast to West Coast, right? So that's about 70 milliseconds round trip. If you're shipping from East Coast to Europe, that's about 150 milliseconds. That is something which we cannot beat. Okay, so though we made XDR like extremely efficient, it is not going to beat this like 150 milliseconds round trip latency kind of thing. So across large distances, it may not make a huge difference in ship latency. But what is interesting is people also use XDR with close proximity, like just in the next building for the sake of DR. So, and people have been asking us like, we want a much lower latency system. So in the older design, right, we used to have, because we were having digest log, we used to have buffers of 100 milliseconds, 500 milliseconds, just before deciding to even process a record. So now all those latencies are gone. So if you are having data centers in close proximity, you will actually see a huge difference in the shipping latency in the new XDR. Okay. So the other question. So are the threads used to ship XDR records and reads and writes at the same time? Yeah. So now the same service threads process both XDR reads, your regular read transactions, write transactions. So what we did for the service threads is now basically the default configuration, right? We actually spin up about 5 service threads per core. So now like you have 5 service threads like processing all your regular read and write operations as well as XDR read as well as XDR shipping. But we made sure like all of this is very efficient. Okay, somebody is feeling happy about reduction of 375,000 lines of code. Thanks. We are also proud. When I say duplicate, it is already. When I say duplicate, it is. Sorry, I did not get this question from Kavya Shivsankar. If you can reframe, maybe I'll take it up again. So there was a question about how does the conflict resolution be handled in bidirectional replication. So that problem still remains. So if you have an active DC and you are updating exactly the same record, a single record, exactly at the same time, and the shipping gets crisscrossed, so that active conflict still remains, and there is something which is in the roadmap which we are planning down the line to handle those kind of conflicts. But as I mentioned in the beginning of the talk, we also have this multi-site clustering, which is much better at handling these active write conflicts. So because it's a single cluster which is spread across multiple DCs. So if consistency is a lot more critical to you than the latency, that is something you should really consider. XDR will address this problem, but it may not solve the problem completely because of the fundamental fact that XDR shifts these records in an asynchronous way. I think there is again the same question, will LUT help avoid consistency issues with active setup? The answer is the same. So any plans to add event notification about record expiration due to TTL eviction? Answer is yes. So I forgot to mention like one thing about the change notification. There were also actually some a missing in detail or a very critical information. We were not shipping the user keys when we were shipping events about deletion, because earlier all of it was driven based on the primary key entry itself, and because the entry is completely gone, we no longer know what is a key. So what we did in the new XDR is when there is a delete event or an expiry event or a eviction event, all 3 different forms of deletes, we actually leave something called XDR tombstone. Okay, so if you are writing these keys with user key, we will remember that. So if the record gets deleted by any of these 3 operations, we do ship the entire information to change notification system also. That's one thing we did new in the new XDR. So will this Aerospike 5 be available for enterprise customers? Yes. As far as I know, you don't need any new license for this, all the nicety that we have in XDR 5.0. So somebody was asking, is there an overhead in CPU because of using the same Aerospike process? Obviously, there is some cost, but I bet it will be less than what we had in the previous XDR, because even in the previous XDR, we used to have its own threads, which used to process a lot more threads. Now we are actually piggybacking on the service thread. So we are net, we are actually reducing the number of service threads. So overall, I think it will still be more CPU friendly. So do you see any performance? Okay, I will take only a few questions. I think we are almost on, time is up. Do you see any performance bottlenecks in cloud platforms? Nothing new, so nothing specific to cloud. Somebody asked, is it essentially more than 2 DCs? Yes, definitely. You can. So I think the largest we have seen is in our existing customer deployment is um, uh, 8 DCs actually. So one cluster replicating to 8 different DCs. Okay, I think I need to stop here. We will probably answer some of these questions offline if there's a way. Definitely, you can leave some of the questions in Ask Aerospike. That is in the lobby section. Okay, so then I will end my session here. Thanks all for listening and thanks for all the questions.